It's time to start studying some more of the conic sections. Now, in previous courses, the 2-unit and the extension 1, we've looked at some of the conic sections, namely the parabola and the circle. Now we want to look at some others, in which we're going to call the ellipse and the hyperbola. So we're going to deal with the hyperbola, the ellipse first, and then deal with the hyperbola. But how are all these generated? Well, basically, if you get a line and rotate it about a fixed axis around a vertex angle here, at its vertex angle, you get two cones. So the upper and lower nap there, with the vertex in the middle. So that's where we start to generate our cones, the two cones there. So what we can do then is start to take slices of that. So if we start to cut them off, depending what angle we cut them at, we're going to get different types of shapes being created as a plane shape on the cone. So if we take a slice straight across, so it's perpendicular to the axis, then we're going to get a circle. If we get a slice that is, well, it's going to have an angle that's greater than 0 degrees. That's an angle of 0 degrees because it's perpendicular to the axis. Or if we take the axis at being 90 degrees, that's going to be greater than 0 degrees, but not as great as that angle alpha that we have, or phi we've got there. Depends on what we want to call it. So the angle there, it's not as great as the slant angle. So it's somewhere between 0 and the slant angle. Any one of those, we get an ellipse. If we cut it at the slant angle, so be parallel to the sides of the cone, we're going to get a parabola. So you can see that parabola there. And anything that's greater than the slant angle, but less than 90 degrees, or even equal to 90 degrees, we're going to get a hyperbola happening there. So you can see it's going to, from the two cones, we get that hyperbola happening there. So that's where we get it, and there's our angles that we need to do. So if alpha's our slant angle there, so what angle to the axis, then we take the axis at 90 degrees, then the circle will be at an angle of 0. The ellipse getting cut somewhere that's greater than 0 but less than the slant angle. If we cut it at the slant angle, so the same as the slant angle there, trying to get that parallel there, you're going to get a parabola. And anything that's 90 degrees or less than 90 degrees but greater than the slant angle, we're going to get two parts. It's going to hit the curve twice, the cone twice, and we're going to get a hyperbola. So that's how we generate those in the conic sections. The four of them, as I said, we've studied the circle, we've studied the parabola. Let's have a look at the ellipse. Now, the idea of an ellipse, and there's all what you need to know about the ellipse. There's a few different things, and most of it it's pretty straightforward. But check over that. If you can keep checking those dot points, then you'll be covered for this topic. So the idea of an ellipse. Well, let's have a look at a few things. First thing is the equation of the ellipse. Now, I'm taking it in this case to be A is greater than B. We'll see later on what happens if B is greater than A. But an ellipse will be in this form: x squared times x squared over a squared plus y squared over b squared is equal to 1. So if we can get an equation and put it in that form, then we have an equation of an ellipse. Now the a and b are important here because where y would be equal to 0, that would leave x squared equal to a squared to be equal to 1. So we get a and minus a as where we'll cut the x-axis. And similarly, where x is equal to 0, y would equal to b, y squared would equal b squared, so y would equal plus or minus b. There's your y-intercepts. Now, if a is greater than b, we call the larger axis here, because the a's values will be greater, we call that the major axis, and we call the smaller one the minor axis. And if we take part of it, we call that the semi-major axis, or if you're in America, semi-major axis. And similarly, you get the semi or semi-minor axis. So either parts would be, because semi means cut in half. So like we had with the parabola, we're going to have focus and directrix, but except in the ellipse, we've got two. The same will happen with a hyperbola. So we've got foci and directrices, and if A is greater than B, the foci would be plus or minus A times E is greater than 0, and the directrices, X is equal to plus or minus A on E. Now you're probably saying, wait on, what's E? Where did it come from? Now E is not our exponential value, 2.71. That's E takes on a different form in this one. It's called the eccentricity. Now you might have heard that word before. Now eccentricity basically is describing a ratio. Now in a parabola, the eccentricity is 1, and what we're talking about there is the idea that we have the ratio between the foci of the point on the ellipse or parabola or circle or whatever we've got. Any point there, we know by our locus definition is, well, in a parabola it's equidistant from a point and a line, our direct focus and our directrix. Now that has a 1-to-1 relationship. Its eccentricity is 1. Now where we get an eccentricity of something that's less than 1, so it's between 0 and 1, then we'll have an ellipse. So because the distance to the focus is less than the distance to the directrix, so we're going to get a fraction. And the closer it is to 1, that means basically the flatter the ellipse is going to be, because the focus moves closer towards the center of the ellipse and the directrix moves away. The closer it is to a circle, the closer these two are going to be. Now the ellipse, the circle has an eccentricity of 0. We know it doesn't have a directrix. We know it just is equidistant from a point. That's its locus definition. So basically, in that case, your focus is on the circle itself, as well as the directrix would be a tangent as such to it. So we don't have a focus and directrix for our circle. That's because its eccentricity is 0. But the eccentricity of an ellipse is a fraction. So that's where we're going to get this idea. Because A is greater than B, we have this relationship for the eccentricity. Or we could write it like that. So E squared is equal to 1 minus B squared on A squared. Now B squared on A squared will give you a fraction every time, and 1 minus that will give you a fraction. Taking the square root of a fraction gives you a fraction as well. So we will have that all the time. E squared for an for the eccentricity for an ellipse is always between 0 and 1. So there's some terms about the ellipse. So in our next video we'll start playing around with all these formulas and starting to solve and draw some ellipses up and see how these all start to relate to each other. But we start to learn all these terms, we start to get used to them, start to remember the formula at this point.